Straightforward question. Question says lithium forms body-centered cubic structure. The length of side of its unit cell is 351 picometer. Atomic radius of lithium will be. So basically it's given lithium forms body-centered cubic lattice. So if you remember in body-centered cubic lattice what you have, so this is your unit cell. Now I can make something like this. What happens in body centered cubic lattice? This is the body diagonal. So this is the body diagonal you have. You have one atom on this corner. So this corner contains one atom. So this is the only part of atom I am showing. This corner also contains one atom. Only part of atom I am showing. And this body has another atom. So basically what is happening, this radius is r and this is the diameter, this is 2r, and this is again radius, so this is r. So this total distance is 4r, and this is equals to, if this length is a, that is the cube as length is a, then this is root 3a. You can prove yourself. In bodies in cube, body diagonal length is root 3 times a. So from here I can find r is equals to root 3 a by 4. Now if I plug the value of a, that is 351 picometer, so r is basically equals to root 3 by 4 into 351 picometer. I can do this calculation. So root 3, so I will have, so let us use my calculator. So a square root of 3 multiplied by root 3 into 351 and this divided by 4. So this comes out to be 151.98. So this is around 151.98 picometer. So radius of each atom is 151.98 picometer, around 152. So the answer is the 3 in this case. So option 3 is the correct answer. Now this is again a straightforward question, formula based problem. Question says Kf for water is 1.86 Kelvin kg per mole. If your automobile radiator holds 1 kg of water, how many grams of ethylene glycol, that is C2H6O2, must you add to get the freezing point of solution lowered by minus 2.8 degrees centigrade? So basically delta TF, that is the lowering in freezing point, this is given to you 2.8 degree centigrade. Kf is also given, that is 1.86. Now if you remember, we have a formula, delta TF is equals to I times Kf into molarity. This is a molality basically. So in this case we have molality. Now delta TF is given 2.8 and I in this case is 1 because ethylene glycol CH2OH, and if you dissolve this into solution, this is not going to ionize, that is not going to dissociate. So in this case I is equals to 1. So I is equals to 1, Kf is 1.86, and molality you have, let us say first find molality. Molality is m, so I can find m is equals to 2.8 divided by 1.86. So let us use calculator. So I have 2.8 divided by 1.86. So this is 1.5, so around 1.505. So this is the molality. Now we have to find weight of ethylene glycol in 1 kg water. So we have to find bait of CH2OH, CH2OH. This is your ethylene glycol. Now what is molality? Molality is nothing but mole of solute. So this is nothing but mole of solute, mole of solute divided by weight of solvent in kg. Weight of solvent in kg. And you see in this case weight of solvent that is given 1 kg of water, so weight of solvent is 1, so molality is simply number of mole, so mole of solute. And now mole of solute is 1.505, so I can now write mole of solute that is equals to molality is 1.505. So corresponding we can find weight of solute, that is ethylene glycol, CH2OH. In this case ethylene glycol is a solute. So this multiplied by molecular weight, we can calculate molecular weight. So we have formula is, so you see C2H6O2, C2H6O2. So for molecular weight will be 12 into 2 24 plus 6 plus 32. So molecular weight is, this is 30 plus 30 62 gram per mole. This is the molecular weight. So we have to multiply by this by 62. So let us use calculator. 62 into 1.505. So 1.505 into 62. This comes out to be 93.31. So around 93.31 gram. So basically in this case we have to add 93.31 gram of ethylene glycol. That is answer. If you see, the option 1 is the correct option in this case. So option 1. Now this problem is from chemical bonding chapter. Quite interesting problem. Question says the molecule having the smallest bond angle is. So we have been given 4 molecules and we have to find which will have a smallest bond angle. Now if you see in the periodic table, you have nitrogen first, then phosphorus, then arsenic, and then you have antimony. Nitrogen is the most electronegative and antimony is the least electronegativity. So you see electronegativity decreases in this order. So electronegativity decreases. Now if you see the shape of all these molecules, all will have same kind of Lewis-Dot structure. Only thing is central atom will change. So you have ASCl3. This is the atom. Now you see this is a 4 groups. So this will be sp3 hybridized and the shape will be basically tetrahedral. So structural will be tetrahedral. Now if I make this tetrahedral arrangement, what will happen? It will have something like this. It will have arsenic in this case is here and the lone pair will be here, and the chlorine, chlorine, chlorine. So if you see the bond angle, bond pairs, the shape will be basically pyramidal. Now important point is we have to find about this bond angle. You see, now let us go into detail. So if I see arsenic, what is happening? We have bond pairs. So this is bond pair with chlorine. This is again another bond pair. This is attached with chlorine. We have to find what is this bond angle, how this bond angle will vary. If I change the arsenic, nitrogen, phosphorus, so I have to change. One time we will have nitrogen, another time phosphorus, arsenic, and then finally if I have antimony, how this bond angle will change. Now see, in case of antimony, this is least electronegative, so this electron cloud is mainly away from the atom. In case of nitrogen, electron cloud is towards the central atom. Are you getting or not? So what is happening? if we have nitrogen atom, this bond pair is towards the central atom, more towards, so electron cloud will have high density here, so electron cloud will have high density here, so this repulsion will be high, so this bond angle will increase. But in this case, if you see, the electron cloud is mainly away from the central atom, so you have more electron cloud here, you have more electron cloud here, so repulsion will be less, so bond angle in this case, since the repulsion is less, bond angle is slow, so in this case I can say less bond angle I will have, and this case we will have highest bond angle, so more bond angle. What is the reason? We will explain once again what is happening. This bond angle, this bond pair, in case of arsenic, it is away from the central atom. So in case of ASCl3, bond pair is away from the central atom. Away from the central atom. So repulsion is less. Repulsion is very less. And this repulsion is of course between bond pair and bond pair. So bond angle is very high. So bond angle is greater, larger. And the reverse is the case with basically arsenic, and reverse is the case with ASCl3. So ASCl3 will have a smallest bond angle. So in this case answer should be SbCl3, that is the lowest electronegative, should we have a smallest bond angle, that is option is 2. So in this case option 2 is the right answer. So option 2 is the right answer. Now this is a fact based question. What is DDT among the following? If you remember, DDT is nowadays banned because this is a biodegradable, non-biodegradable. That is basically it cannot be biodegraded, and that's why it is banned. So I can say this is not a fertilizer, this is not a biodegradable pollutant. If a biodegradable, why it should be banned? So this is not a gas also. So this is a non-biodegradable pollutant. So basically in this case option is 3. So this is a straightforward fact-based question. Option is 3, and I can say this is, so DDT is banned because it is non-biodegradable. So this is non-biodegradable, and that's why it is banned. Now this question is from Ionic Equilibria chapter, and very straightforward question. Question says pH of 0.1 molar solution of an acid HQ is 3. The value of ionization constant Ka for this acid is. So we have been given pH. So pH for this solution is 3, and the molarity is also given, that is 0.1 molar solution I will have. pH is 3, this means concentration of H plus is 10 to the power minus 3. Now this is very easy to do this one. HQ, this is the weak acid, and it will dissociate, it will form H plus plus Q minus. Now this is 0.1 m. Initially this is 0.1 m, this is 0, and this is 0, and H plus is 10 to the power minus 3. Since H plus is 10 to the power minus 3, Q minus also has to be 10 to the power minus 3, and the HQ will remain zero point 0.1 minus 10 to the power minus 3, and this is approximately equals to 0.1. So if I make this assumption, and the K value at equilibrium we will have 10 to the power minus 3, that is the concentration of H plus into concentration of Q minus, that is again 10 to the power minus 3, and this divided by concentration of HQ, that is 0.1. So this comes out to be 10 to the power minus 5. So in this case answer is 2. So B case dissociation constant, option 2 is basically a right answer in this case. This is a very straightforward question. This is again a fact based question from inorganic chemistry chapter. This is from hydrogen, and question says very pure hydrogen can be made by which of the following process. If you remember, one question in IIT JEE this year last year asked on the same idea, very pure nitrogen, only in this place of hydrogen you will have nitrogen. Very pure nitrogen can be made by which of the following process. This question is asked in the last year JEE. This year they have asked in AIEEE, they are following IIT JEE, so they are asking very pure hydrogen can be made by which of the following process. And now this can be made by electrolysis of water. So if you do electrolysis of water, you will have hydrogen that is coming very pure. So in this case I can say option 2 is the right option. Option 2 is basically right answer. Very pure hydrogen can be made by electrolysis of water. So this is electrolysis of water. So you can use electrolysis of water to get the very pure hydrogen.